Hello and I welcome you to my video classes on concrete technology. Today we are mainly discussing about a numerical example of mixed proportioning. It is without admixtures and it is a video number 2. Right, continuation part of video 1 and myself Vishwanath, our team. So today we are mainly focusing on remaining steps. Right, step number 6, proportion of volume of coarse aggregate and fine aggregate content. Step 7, mix calculations. Step 8, mix proportions for trial number 1. Step 9, adjustment on water, fine aggregate, coarse aggregate. Step 10, mix proportions after adjustment for dry aggregates. So here it is, we know the given values of problem. It is a M40 grade, and here they given us some data on materials, right? Grade of the concrete is M20, type of the cement is PCC, and maximum size of aggregate is 20 mm, and exposure condition is severe for RCC. Workability is 75 mm, and method of concrete placing is non-pumpable, and the degree of site control is good. Type of aggregate is crushed angular. Maximum cement content not excluding fly ash 450 kg per meter cube, and chemical admixture is plasticizer normal. And here we have to remember in this in this video, maximum normal size of aggregate is 20 mm, very important. So next important data on the test data of material. So here cement is PCC, but what we have to remember to solve the problem is specific gravity of each material. Specific gravity of cement 2.88, specific gravity of chemical admixtures, and chemical admixture is superplasticizer. Sorry. Next is specific gravity of coarse aggregate at saturated surface dry condition SSD is 2.74. Fine aggregate at saturated surface dry condition 2.65. Next is chemical admixtures. Specific gravity of chemical admixtures 1.145. And these four values are very important because the remaining steps require mainly these kind of datas. Next is water absorption, and even these two data is very important. Water absorptions for coarse aggregate and fine aggregate each they given, and for coarse aggregate it is 0.5, fine aggregate is 1%. And moisture content of aggregate as per IS 2386 part 3, coarse aggregate nil, fine aggregate nil. Then remaining data of sieve analysis. So sieve analysis for coarse aggregate conforming to table 7 of IS 383, and very important is fine aggregate conforming grading zone 2. So here it is conforming zone 2, very important. Now we'll begin with the first step as a revision, target strength for mixed proportioning. So how we calculated in last video using these three formula, and which one will get higher value, that will be selected as a target strength. And here unknown is S value in the first equation, and unknown is in the second equation is X, and both the values we are getting from table, and from the table codebook of 2019. Table 2 gives S value, right? We have seen from table 2 how to calculate the how to get the value of standard deviation for, because M20 is, and for that it is 5. And similarly X value, it is for M20 6.5. So after substituting in the equations, right, so we got the values, but in these values our value is highest target strength is 48.25 Newton per mm square. That's what we taken a target strength as 48.25 mm Newton per mm square. So next step is approximate air content. This we calculated directly from the table 3, right? From the table 3 we have a serial number in first column, second column is nominal maximum size of aggregate. So here it is 20 mm for us, and for 20 mm interrupt air as a percentage of volume of concrete is 1%. So that's what we taken 1% as a approximate air content. This is also very important for upcoming steps, just note down. So next is we calculated the selection of water cement ratio. So here water cement ratio we taken from the figure 1. So if you see the figure 1, here it is in y-axis 28 days compressive strength of concrete. So how much we got the strength of the concrete is 48.25, and for 48.25 we are seeing the curve 2, so then we are getting approximately 0.36. So when we got 0.36, it is greater than, it is a lesser than 0.45 of severe condition of IS 456 table. Why I am taking this? Because you can see here it is a IS 45 table 5. Here they are telling that minimum requirement of water cement ratio, and here it is they mentioned RCC, means reinforced concrete. For here they given multiple data, but we are focusing on only water cement ratio, right? So here they mentioned in the data it is a severe exposure condition. For severe exposure condition, minimum water cement ratio should be 0.45, but what we got in the calculation is less than 0.45, hence it is okay. Why? Because if it is a less water cement ratio, then it is good for to gain the strength, and it is good. So that's what okay. So now onwards, what is the cement water cement ratio in this formula? 0.36, right? So next we will go for step 4, selection of water content. So that selection of water content we are taken from the table 4, and you can see here table 4 from the code book. Here they given serial numbers, nominal size of aggregate, water as water content in kg. So what is the nominal size of aggregate? 20 mm. If it is a 40, then we have to see the 40. If it is a 10, then we have to see for 10. So for 20 mm of aggregate we are getting 186, but here it is for 50 mm of slump. These values are for 50 mm slump, right? But for in our given data they given 75 mm of slump. So to calculate for 75 mm slump, then we have to take some values. So here it is the note, 3% increase for every 25 mm slump. If we are increasing more than 50 with respect to 25 mm, then we have to take 3% extra, correct? So that's what we are taken 3% extra of 186. So for 50 mm it is 186, and for 3% extra it is 3%. Then we are getting approximately 191.58 kg of water content. But here we are using super plasticizers. We know what you mean by super plasticizers. They are the water reducers. From the trial we are getting up to 23% of water we can reduce. So when you reduce the 100% of water of 23%, then we are remaining with 77%. That's what. Now hence the water content is now we are taking only 0.77. Why? Because 77% is water required, right? So that's what we are getting finally, 148 kg of water. So now what is the water content? 140 kg. So next step is calculation of cement content. So this cement content we calculated with the equation. We have an equation that water divided by cement equal to 0.3, correct? So now what we required cement. Then we are like, if you want to calculate the cement, then we have to send that cement into right side, and that is equal to cement of the content equal to water divided by water cement ratio. So what is the water content? 140 kg. And what is water cement ratio? 0.36. So then after that we are getting the value of 412 kg per meter cube, right? Very easy, and you have to calculate very carefully, right? So next is from table 5 of IS 456.45 of IS 4.456, they are telling that minimum requirement of cement for severe exposure, correct? So earlier we calculated minimum requirement of maximum requirement of water cement ratio, correct? So here it is, you can see for RCC, here it is a RCC, and for here you can see first one, it is minimum. Earlier I told it is a maximum water cement ratio. Sorry, they make the correction, it is a maximum, right? So but here it is minimum cement content. And for which condition? Severe condition. For severe condition minimum should be 320 kg, but how much we got from the calculation is more than 320, right? So then no problem, we'll keep it up. How much we got in the calculation? In the calculation we got 412, right? So then no problem, 412 is the required cement for the concrete, right? 412 kg per meter cube. So remember all the main values. Main values means water cement ratio, cement content, water content, all are very important. So next is step 6, very important. Now we are focusing more on this step. Why? Because all the 5 steps are covered in first video. So now in step 6, proportion of volume of coarse aggregate and fine aggregate content. So here what we are calculating? We are calculating volume of coarse aggregate and volume of fine aggregate. So I'll tell you how to calculate the aggregates volume. So here from the table 5, the proportioning volume of coarse aggregate corresponding to 20 mm size aggregate and fine aggregate zone 2 for water cement ratio of 0.50. So what they are telling, just will go for the table. So here it is a table and it is from code book, right? So here it is table 5. What table 5 indicates? Volume of coarse aggregate per unit volume of total aggregate for different zones of fine aggregate for water cement ratio, right? And what is the water cement ratio is 0.5, correct? So here we have what is the size of aggregate in a given data? 20 mm, correct? Nominal size of aggregate is 20 mm. And what is the zone of the fine aggregate? Zone 2. So in the zone 2, how much we are getting the proportion volume? 0.62. That's what they are taken. That is 0.62. Correct. So next is, but our water cement ratio is how much? 0.36. Therefore, volume of coarse aggregate is required to be increased. Volume of coarse aggregate is required to be increased to decrease the fine aggregate content. Correct. So then as the water cement ratio is lower by 0.14. So how you got a 0.14? Because maximum is, sorry, here it is given data is for 0.5, but how much we are getting in the calculation? 0.36. Then how much is the change in the water cement ratio? 0.14. Correct. It is a it is less, I means minus 0.14. So in that condition, the proportion of volume of coarse aggregate is increased. Means we have to increase the volume of coarse aggregate. Then how to increase the volume of coarse aggregate? By using this simple understanding. At the rate of minus plus 0.01 for every plus minus 0.05 change in the water cement ratio. So how much is the change in the water cement ratio? 0.14. Then how much you have to increase the content of coarse aggregate? At the rate of 0.01 for every 0.05 change in the water cement ratio. Then if you calculate, we will get approximately we will get 0.028. We will get approximately 0.028 as increased in the coarse aggregate. Earlier how much we got? 0.62 plus 0.028. Then we are getting total coarse aggregate for water cement ratio of 0.36 is 0.648. Very important, just note down this value, it is useful for next steps. Next is volume of fine aggregate, and we know what is 1 indicates total volume of aggregate. Then we know the volume of coarse aggregate, just remove the out of total, remove coarse aggregate content. Then we are remaining with 0.352 as a fine aggregates, right? So next we will go for step 7. Here it is mix calculation. Mix calculation means in terms of meter cube, right? The mix calculation per unit volume of concrete shall be as follows. So it is total volume is how much? We are taking 1 meter cube. We are taking in a unit form, unit form. Here it is 1 meter cube. So in the 1 meter cube, what is a part of air content? That is a A. So just remember A step, B step, because these steps are these values, like no, if I want to use total volume, then I'll indicate A. A means what? 1 meter cube, right? Second one is volume of entrapped air in a wet concrete. What is the air and air volume? It is 1%. So divided by 1000, then we are getting 0.01 meter cube of air content. Correct. So next is C, volume of cement. So now to calculate volume of cement, we have a simple formula. That formula is mass of cement divided by specific gravity of cement into 1 by 1000. Correct. So then we where we will get a mass of cement? That is from calculation. So in a step 5, we calculated the total mass of cement. So how much we got the mass of cement? It is 412. Correct. So 412 is the mass of the cement, right? So then specific gravity. Specific gravity, it is given in the problem, and substitute the same value 2.88. Then calculate, we will get volume of cement is 0.143. Correct. Volume of cement is 0.143 meter cube. Next is similarly we are calculating for volume of water. Same formula, mass by specific gravity. So mass of water divided by specific gravity of water into 1 by 1000. Then mass of water is 148. So where we got 148? From step 4, right? So we got 148 liter water. Then substitute the specific gravity of water, that is 1. Then we'll get a value of volume of water is 0.148 meter cube. Next continuation part, we calculated the air volume, we calculated the cement volume, we calculated the water volume. What is the remaining? Super plasticizers or chemical admixtures, right? So then the mass we are not calculated, same formula we are using. But how to assume the mass? Because we assumed earlier step 1% of cementitious material. How much is the cement? Right? 412. Right? Here it is 1% by mass of cementitious material. And we have 412 kg of meter cube of cement. And if you take 1% of it, then we are getting 4.12. Then specific gravity of chemical admixture, that is 1.145. Right? If you calculate, then we'll get a volume of chemical admixture is 0.0036 meter cube. So next is volume of all in aggregate. Volume of all in aggregate. Then we have a simple formula, as I told. Here A means what? A step. B means B step. C means C step. D means D step. E means E step. And substitute all the values, we will get total volume of aggregate is 0.695 meter cube. Very simple, don't get confused. Just substitute the values, and if you substitute the value, you will get total volume of all in aggregate is 0.695. Correct. So next is mass of coarse aggregate. Step H is mass of coarse aggregate. So how to calculate the mass of coarse aggregate? Very simple formula. G means here it is a step G, not a specific gravity. It is a step G into volume of coarse aggregate into specific gravity of coarse aggregate into 1000. If you follow this simple formula, and you can solve very easily. Correct. So now what is the G value? Correct. It is from the G step, that is the value of 0.695. Correct. So then volume of coarse aggregate, as I told, it is, we calculated the earlier step, it is 0.648 into specific gravity of coarse aggregate 2.74 into 1000. Then we'll get approximately, after the calculation, 1234 kg of coarse aggregate. Correct. And you calculated the volume of coarse aggregate from step number 6, right? Just go through that, and you will get a value of coarse aggregate is 0.648. Then after substituting, we will get approximately 1234 kg of mass of coarse aggregate. It is mass of coarse aggregate. Next, similarly for mass of fine aggregate, same formula, G into volume of fine aggregate into specific gravity of fine aggregate into 1000. So then we know what is the G value, 0.695 into volume of fine aggregate from step number 6, 0.352 into specific gravity of fine aggregate 2.65 into 1000. Then we'll get approximately 648 kg of fine aggregate. Correct. So then if you see the step number 8, mixed proportion for trial number 1. So it means that whatever we calculated in earlier steps, they are taking in one place. Correct. Almost it is a mixed design, but correction will go for 9 step. Right. So here it is. What is the cement mass? It is 412 kg per meter cube. Right. Water is 180 kg per meter cube. Then we have fine aggregate SST 680 kg per meter cube, just we calculated. Then coarse aggregate is 1234 kg per meter cube. Chemical admixture is 1% of cementitious material, 4.12 kg per meter cube. Free water cement ratio is 0.36. Just we have to we have to remember these names. Then we have to write all the calculated values. Correct. Very simple. Step number 8 is very simple. Next we will go for step number 9. Adjustment on water, fine aggregate, coarse aggregate. If the coarse aggregate and fine aggregate is a dry condition. Correct. So here also we have a simple formula. No need to worry. Just if you remember with a trick, this simple formula we can calculate for both fine aggregate and coarse aggregate. And here it is a formula is mass of fine aggregate in SSD condition. Mass of fine aggregate in a SSD condition. Just go for step number 8. You will get to know what is the mass of fine aggregate in SSD condition. It is 648. Then 1 plus water absorption. So the given water absorption value in a given data, it is 1%. That is, we substituted 1. Then if you calculate, you will get fine aggregate in a dry condition is 4642 kg per meter cube. Earlier it is how much? 648 with a moisture condition, but here it is 642. Means how much is the reduction? Almost 6 kg of fine aggregate is reduced. Correct, in a dry condition. Just remember, SST means in a wet condition, dry means dry condition. Similarly, we are going for coarse aggregate. Same formula. Mass of coarse aggregate in SSD 1 plus water absorption divided by 100. Then mass of coarse aggregate in SST is 1234 and 1 plus 0.5% of water absorption for coarse aggregate. Then we will get the value of coarse aggregate in dry condition is 1228. Earlier is how much? 1234. Now we are getting 1228. Means how much is the reduction? Here is also almost 6 kg of kg per meter cube of reduction in the coarse aggregate. Just remember, coarse aggregate in a SST condition, coarse aggregate in a dry condition. Correct. So we'll go for next. So next is we have to calculate the extra water to be added for absorption by coarse and fine aggregate. So here it is what? Extra water to be added for absorption by coarse and fine aggregate. So how to calculate this? We have a simple formula. The formula is mass of coarse aggregate in SSD condition, mass of coarse aggregate in a dry condition. What you calculated, if you remember step number 8, so earlier steps, right? You can easily write, because just differ is same coarse aggregate, but first one is SSD condition, second one is dry condition. If you remember this, then you can substitute, and first will be higher value. Higher value means saturated condition. Correct. So then if you calculate, you will get 6 kg, right? 6 kg of water. So 6 kg. So next is for fine aggregate. So fine aggregate, here also same formula. Correct. Same formula of mass of fine aggregate in a SSD condition, mass of fine aggregate in a dry condition, right? And if you substitute the values, you will get 6 kg also here. So 6 kg of water. Correct. So next is the estimated requirement of added water, therefore becomes 148 is earlier. Correct. 148 kg of per meter cube of water, and now is 6 plus 6 means additional water added. So what is the total quantity of water required? 160 kg per meter cube. Correct. So next we will go for next step, is the step number 10. Very important, last step. So what we have to do? Similarly, how we did in step number 8, we have to remember this cement, right? And we have to write down calculated value of cement content. So how much we got? 412 kg per meter cube. Next is water. Water. So here we calculated the water. Earlier it is 148 plus 12. Then we got 160 kg of water. Next, fine aggregate, dry, 642. Coarse aggregate, dry, 1228 kg per meter cube. Chemical admixtures, 4.12. Free water cement ratio, 0.36. So just remember, we are taking the aggregate in terms of dry condition. Don't get confused with the SSD. Correct. So I think you understood, right? So thank you so much for watching this video.